Warahmatullahi Wabarakatuh, and hello everyone. So today I'm going to present my slide about the subject thermodynamic. But before I begin, let me introduce myself first. My name is Syafiq bin Hamzah, and the topic that I'm going to present to you is the first law and the second law of the thermodynamic. And our lecturer name is Dr. Nordin bin Haji Sabri. First law of thermodynamics states that energy can be neither created nor destroyed during a process, but it can only change its form. This law, also known as the conservation of energy principle. If you can see right here, this is the mathematical formula for this law, where the delta U is the change in internal energy of the system, Q is the heat added to the system, and W is the work added to the system. Next, we are going to describe about the type of system that we have. The first type of system is the open system, where the open system is an exchange mass and energy, usually in the form of heat with its surrounding. So this type of system will allow the transfer of what energy and the mass. Next, we are going to the second system, which is the closed system. The closed system only allow the transfer of energy but not the mass. And the last one is the isolated system. This type of system is not allow the transfer of energy and heat. Next, we are going for a closed system or a fixed mass. For a closed system, the net energy transfer to the system as heat and work is equal to the net increase in total energy of the total system. In the simple way, is the energy in minus energy out is equal to delta energy of the system. Next, we are going for the sign convention. Or the sign convention for the heat transfer. When the heat into the system, it is positive value. But when the heat out from the system, it is negative value. Next, we are going to move for the work transfer sign convention. The sign for work is negative when the work into the system, and meanwhile the value will be positive if the work out from the system. Next, we are going to isothermal process. Isothermal process is a process where the temperature is constant. In order for an isothermal process to take place, we must assume the system is in contact with a heat reservoir. In general, we assume that the system remains in equilibrium throughout all process. If the isothermal process occur, no change in internal energy, which means the delta U is equal to 0. Next is the adiabatic process. Adiabatic process is a process where there is no heat flow into or out of the system. In the terms that we will easily to understand is when it said that it is thermally isolated. Then it's also when it say that the thermally isolated, so there is no energy transfer. When there is no energy transfer, the Q will be automatically will equal to 0. Next, the next process is the isovolumetric process. This process is where the volume don't change. When the volume don't change, it means that no work is done. So the WE will equal to 0. So right here is the graph that show that where's the isovolumetric, this one, where you can see that the V is constant, the change is only the pressure. Next, this is the summary for the past 3 slides that I have explained. For the first one is the isothermal process, where the T is constant, where the T is the temperature, and the first law that we can make it become even simpler is when the delta T is equal to 0, it will make the delta U equal to 0. So the first law will become more simple, which is the Q will equal to W. Next, we are going to isobaric process, whereas the pressure is constant. This one, when the pressure is constant, the formula for the first law is changed a little bit, where the Q will equal to delta U plus W, where the W will equal to P times delta V, where is the delta V is the change in volume. So this one is the last form for the first law for this process, which is the isobaric. Next, we are going to isovolumetrics. For isovolumetric process, the V is constant, where is the volume. When the delta V is constant, which is 0, it will make W also become 0. So the first law will become Q will equal to delta U, where is the change in internal energy. Next is the adiabatic process. In this process, the Q is constant, where is the no heat transfer between in or out the system. So the first law that we can make it become even simpler is the delta U, where is the change in internal energy, is equal to negative W, whereas the W is the work. This one is the example that which we will use the first law of thermodynamics to solve it. It states that a total of 135 joule of work is done on a gaseous refrigerant as it undergoes compression. If the internal energy of the gas increased by 114 joule during the process, what is the total amount of energy transformed as heat? Has energy been added to or removed from the refrigerant as heat? Then the first one, we need to imagine the diagram, which is this one. This is the diagram, where is the 140 joule is the delta U, and the work is the negative 135, where is the work enter. This is why it is negative. And the first one, we must write our first law of thermodynamics, and then we just state in the value, and we got the Q will equal to negative 21 joule. Since the Q is less than 0, the energy has been removed from the system, which is the sign conversion. If the Q we got is negative, it means that the heat is removed or out from the system. Last but not least is the summary of the first law of the thermodynamics. What first law of thermodynamics tells us? The first law of thermodynamics states that a work can be converted into heat and heat into work. And first law also makes no distinction between forms of energy, silence about the possibility of energy conversion. First law is not sufficient to predict whether a system will or will not undergo a particular change. Next, first law also is a necessary condition but not sufficient condition for a process to take place. Next, we are going to the second law of the thermodynamics. The second law of the thermodynamics states that the entropy of an isolated system never decreases because isolated systems spontaneously evolve toward thermodynamic equilibrium, and the changes in entropy also can be never negative. In this slide, there is a sum of the condition which introduced to us that using the second law of the thermodynamics, whereas the first one is the cup of coffee does not get hotter in cooler room. Next, transferring a heat to wire will not generate electricity, and the last one is the transferring a heat to pedal will not cause it to rotate. This is the picture for the above phenomena. Next, I'm going to explain to you what is the major use of this second law of the thermodynamics. First one, the major use of this law is it may be used to identify the direction of the process. The process must be in one way and cannot in reverse direction. The second one, this law also asserts that energy has quality as well as quantity. The second law provides the necessary means to determine the quality as well as the degree of degradation of energy during a process. The third one, which is the last one, is this law also used to determine the theoretical limit for the performance of commonly used in energy systems such as heat engine and refrigerator, as well as predicting the degree of completion of chemical reaction. Next is the second law of thermodynamics, which is the Kelvin-Planck statement. Kelvin-Planck states that it is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. From this statement, we can state that no heat can have 100% thermal efficiency, and this is not this is not due to the friction or other dissipative effect, but it is due to the limitation that applies to both the idealized and the actual heat engine. Here is the example picture that I have shown, which is the energy reservoir, and this is the heat engine. Next is the second law of thermodynamics, which is the Clausius statement. Clausius state that it is impossible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a lower temperature body to a higher temperature body. From this statement, we know that a refrigerator can't operate unless its compressor is driven by an external power source such as electric motor. Next, it is because it will make the net effect on the surrounding involve the consumption of some energy in the form of work in addition to the transfer of heat from colder to warmer body. The last one is the summary of the second law of thermodynamics. The first one, the second law of thermodynamics indicates that all heat cannot be converted into work. According to the second law of thermodynamics, heat will only be transferred from high temperature to lower temperature and not vice versa. Second law also states that whether it is possible for energy transfer to proceed along a particular direction or not. Next, a cycle can only occur if it satisfies both the first law and the second law of the thermodynamics. The last one is the first law of thermodynamics is a quantitative statement, and the second law of thermodynamics is a qualitative statement that we must understand. That's all for me. Thank you.